Hello friends, today we will see topic number 13 as a thermal analysis. Introduction. Linear thermal conduction convection problems are formulated using the finite element approach with the temperature as the single degree of freedom variable at each node in the mesh and with the material conduction properties used to form the thermal stiffness matrix to be solved. ANSYS Workbench includes capability for modeling many types of thermals and the thermal stress problems of interest. To practicing engineers, the temperature distribution found at each thermal analysis node can be used with the equivalent structural model as the inputs for finding stresses caused by temperature changes. Important terms used in thermal analysis, transient thermal analysis determine temperatures and other thermal quantities that vary over time. Many heat transfer applications involve transient thermal analysis such as heat treatment problems, electronic package design, nozzles, engine blocks, pressure vessels. Types of thermal analysis. ANSYS supports two types of thermal analysis. First one is a steady state thermal analysis determines the temperature distributions and other thermal quantities. Steady state loading conditions. A steady state loading condition is a situation where heat storage effects varying over a period of a time can be ignored. Second one is a transient thermal analysis determines the temperature distributions and other thermal quantities under conditions that vary over a period of a time. Steady state thermal analysis of a car disc brake rotor. We will see this car disc brake rotor in our ANSYS workbench. You can see how a disc brake works. This one is there. Pistons, calipers, wheel attaches here. Hub is there, rotor is there, brake pads is there. We will analyze this product. Gray cast iron model is there, disc rotated with the holes. Heat sink. Start ANSYS, begin a new simulations, attach the beam geometry, check the unit simulations, geometry from files, return to design modelers, and start a new simulations, contact. Transient thermal analysis of pistons. We will see this transition, the transient thermal analysis in ANSYS also. This is used to determine the temperatures and the thermal quantities that changes over time. The loads applied in transition thermal analysis are the function of a time. The temperature applied is about 10,000 C and the temperature distributions means Celsius and heat flux is noted for a different element. Structural analysis is performed to observe the deformations and the stress absorbed by the pistons when the pressure of 3.5 MPa megapascals is applied on the pistons with the piston pin begin being constrained and frictional support are given for piston ring. This is the result you can see. We will see all this in our ANSYS workbench. Open the ANSYS. After that, select steady state. You can see drag and drop. After that, engineering data is completed. In geometry, you can see import import the file when you are saved as outside. In geometry, you can import. I am imported this drawing rotor disc brake and after that create a model. Go to the this page and double click on model. It is a generated model. Now mesh, right click and generate mesh. generated, mesh is completed. After that, in steady state thermal, you need to add temperature here, temperature, and click below side here, this one, and apply. After that, steady state thermal, and add convection and control, move somewhat, control and select all and apply.